Okay guys, I will show you how to get the data for the lab motion with constant acceleration. You open the simulation and this lab has 4 cases. The first case is the guy speeding up from the tree to the house. So you put the guys at the house, at the tree. The initial velocity is 0. And we are going to put an acceleration of positive 0.5. And now you click play and you try to stop the guy every half a second. If you use the playback option is easier, so you could see what's happening. You pause it after the house and then you click the playback button and you start collecting the data. Again, this lab is going to contain 4 tables. This is the first one. The guy is speeding up to the right. The initial position is the tree, that is at negative 8 meters. The initial velocity is 0 meters per second, and the acceleration is positive 0.5 meters per second squared. This acceleration is what was different from the previous lab. In the previous lab, the acceleration was kept to 0, and in this lab, the acceleration is positive. The guy is going to speed up to the right. If the acceleration is negative, the guy speed up to the left. Now you make the table, time in seconds, position in meters, and the first at time 0, the guy was at the tree. Now you keep moving this tab over here. You can put it faster, slow, but the idea is that now you can pause it every 5 seconds. If you don't get exactly 3.5, look like right now I got 0.7. You write the data 0.7, the position is negative 7.875. Play 1.9, etc. And you keep getting the data. When you finish, let me show you from the previous class, you will get something like this. And this is how you get the data. Now for the second table, this one you are supposed to do it yourself, is speeding up to the left. So in this case you reset the simulation, yes, and put the guy at the house, positive 8. Initial velocity 0, but now the acceleration you put negative 0.5. And now the guy is going to speed up toward the tree. You pause it at the tree. Now you can click the playback button and pause, play and pause, and collect the time and position data. And this is the guy is initially at the house, positive 8 meters. The initial velocity is 0 meters per second, and the acceleration is negative 0.5 meters per second squared. And this table too, you're supposed to do it on your own. At time 0, the guy was at the house, and you keep on getting the data. So in this case, when we graph the data, we show you that on the second video. In the second video, I will show you how to do this graph. That, as you notice, when you plot position versus time, you see that this is a quadratic. This is a quadratic function. The position versus time is a quadratic function, and you do the same thing over here. This one you do it on your own in Sheets. That's the second video. I will show you how. The guy is over here at the house, and you're going to see what's happening, how this graph look like. And yes, it's going to be, obviously it's going to be quadratic. So the first day in the lab, you were supposed to do, I did this table and this graph, and you were supposed to do this table and this graph on your own. On the second day of the lab, we are going to do something else. In the third table, this one I did it in class, same thing. You're going to collect time and position data, but the guy is going to be initially at -4 meters. He's initially moving to the left, but the acceleration is to the right. So this is like the velocity is positive, but the acceleration is negative. So you put reset the simulation, put the guy at -4, -2, and positive 1.5. And you click play, see the guy going to the left and then going to the right. You click the playback button to start getting the data. So 0, -4, -0.6, -4.9, 1.3, and -5.33, 1.8, and -5.146. And I will pause the video now and continue putting the numbers. So as you see, I just populated the data. In the second video, you are going to see how the position and time graph looks like. You could plot it by hand, but it's time consuming. That's the reason why we plotted in using Sheets. Okay, the last table of the lab, table 4. This one you will do it on your own. So now the guy is initially moving to the right from position 4 meters, but the acceleration is to the left, and you're going to get position and time data. Okay, initial time 0 is a +4, and this table and this graph, you're going to do it on your own. So reset the simulation, put the guy at 4 meters, moving to the right, so +2, but now the acceleration is -1.5. And see, and you click the playback button and you start getting the data. Try to get it half a second. And then you make sure you write your numbers on the table and generate the graph, position versus time, and you do the graph on Sheets. Again, This lab contains 4 tables. Initially not moving and accelerating to the right. Then initially not moving and accelerating to the left. This one you do it on your own. So initially not moving and accelerating to the right. This one I did it in class. Then initially not moving but accelerating to the left. This one you did it yourself. Initially moving to the left but accelerating to the right. This one I did it in class. And the last one that you're supposed to do on your own, the guy is moving to the right but accelerating to the left. 4 tables, 4 graphs is what this lab contains.